So welcome, Dr. Puzant Baliozian, a lead consultant of sector group photovoltaic equipment at VDMA. Yeah, we're all excited. The 15th edition of the International Technology Roadmap of PV. And I'll just ask you, sort of, what are the highlights? I mean, very impressive. Since 1980, I believe, the learning curve with more, I think, with the doubling of production capacity, with the scaling up, the cost has declined 24%. This is pretty amazing since 1980 to 2024. But maybe you can share with us some of the highlights of the report.
Thank you very much for having me. It's a pleasure to be here at SNEC and to talk to you, PV Magazine Group. Actually, we're very proud to have the 15th edition. I mean, I was a researcher at Fraunhofer Institute. I used to read this report and see the advancements of the technology. So, as you said, for every doubling of cumulative manufacturing and shipment, actually the shipment gigawatt scale, we saw a 24.9% average price decrease. And this shows clearly that the technological advancement is ongoing, it keeps on moving, but nevertheless we still have a market situation which also leads to price drops. Other points that are quite interesting are the situation of the N-type wafers. We see a development towards N-type wafers because of the technologies that require N-type wafers, such as TOPCon, IBC, and heterojunction solar cells. And even tandem is being projected to come up in the upcoming years. And in this year, something very special is actually we realized that some of the projections are quite conservative. So we also did an analysis for some of the parameters, taking into consideration only gigawatt scale manufacturers who had a more progressive approach towards the cell technologies and the advancements going on. So yeah, it's quite a summative report. It's available for downloads. And we also invite many of the manufacturers, equipment suppliers, consultants, and EPCs to take part in the contribution of this report.
So it's really a very big collective effort. Yeah.
Absolutely.
So I have 3 questions here, more specific questions about the report. Within N-type technologies, do you expect TOPCon to maintain the largest market share? What are the prospects for HJT and back contact?
The expectations and the projections show that TOPCon is going to be the leader starting from 2024. So starting from this year and up to the upcoming decade, it's going to be the leading technology based on the projections and the results of the report. Of course, it's much easier to project the data of the coming years in comparison to the upcoming decade. It's just like the weather. You can know much better about the weather tomorrow than the weather in 10 years. So, we expect that TOPCon will be a leading technology, followed by heterojunction and IBC. Of course, there are some cell technologies that integrate all the, like heterojunction with IBC architectures and TOPCon with IBC architectures, but based on the results, we see that TOPCon is leading, followed by hetero and then by IBC.
So TOPCon has a rather strong position in the coming years. It won't be replaced too quickly by another technology. Yeah,
the dominance started this year.
Yeah.
And it's expected to continue in the upcoming years.
Yeah. The latest report, the 15th edition, mentions wafers larger than 210 millimeters coming to the market in the near future. Will this likely mean further issues, I guess, complicating issues with non-standard formats? We know for the tool makers, for the production lines, it's a challenge to deal with such non-standard dimensions.
I mean, seeing the industry, how it developed in the past and seeing how it's going moving forward, the wafer formats have always been a particular topic to become more creative with the module designs as well. So when we saw the development of M10 coming up, this also meant that many production lines had to upgrade their lines and had to incorporate tools and equipment that made it easy for M10 wafers to be processed. The manufacturers of equipment directly thought of larger wafer formats as well, trying to anticipate the upcoming trends. So I see from a module design, the manufacturers are going to be very creative. And from the manufacturer's point of view, from the equipment manufacturers, the solutions will be there.
Yeah.
It's just a matter of reducing the costs even further, having creative designs of modules, and making it more cost effective due to the very harsh competition between the manufacturers these days.
Right, right. The report also mentions or focuses on reducing material consumption, and in particular silver. Do you expect copper metallization to take off in the next few years?
Yes, we expect that copper metallization will take part of the market share in the upcoming years, and particularly for the silicon heterojunction solar cells. So we already saw that the development of the silver amount used on cell technologies, starting from the past, it was aluminum BSF, and then PERC and TOPCon and heterojunction. When we track these trends, we see that silicon heterojunction has the strongest curve of reduction.
Okay.
The expectations say that in the upcoming decade, we will have less than 10 milligrams per watt of silver being used for both technologies, TOPCon as well as heterojunction, which means we need to be creative about using alternative process steps, alternative materials, and copper is a designated and a very interesting material for metallization. So I think copper has been interesting since a long time, and it used to be always discussed as a metallization already in the days of aluminum BSF. But in case of silicon heterojunction, there are so many results showing that it is a great candidate, and even in mass production, it is coming up as a huge topic, and pilot lines are working on it immensely.
I'll ask one more question about the learning curve. So 24.9%, I think it is. Very impressive since 1980. But it seems to be still possible to continue that in the coming years. What is your assessment of that?
So talking about the learning rate, it is important to mention the parameters that have a huge impact on the learning rate. So we're talking about increasing the shipment capacity and getting the learning out of that.
Right.
It means we have to improve the efficiencies of solar cells and modules, but at the same time reduce the cost, and that is the learning rate. But in our calculation of the learning rate, we take the price on the y-axis, on the x-axis we have the cumulative shipments, which means market situations have also an influence on the price of the module. So nowadays we have the overcapacity, which is a challenging situation for the entire industry, and further reducing the costs by technological advancements and future competition going on between the manufacturers is still going to be a topic. And I think having these creative ideas, heavy investments in R&D, further developments and cost reductions will take place despite the market situation and despite the overcapacity that has kind of an impact on the average price. So I'm quite confident that this will continue as long as the R&D efforts continue and the development goes forward.
Super. Well, thank you very much.
Thanks a lot for having me. Thanks a lot for having me.